Now we are going to discuss another property that is called vapor pressure, and this vapor pressure is very important in fluid mechanics because of one very important phenomenon that is known as cavitation. What is cavitation? We might have seen that whenever we prepare a tea, when water comes closer to the boiling point, then air bubbles are formed at the bottom, and as they go towards the top level, then they get collapsed and some type of noise is created. Now same thing happen in turbines, pumps or some fluid machinery structure, where if pressure goes beyond certain point, that is known as vapor pressure, then bubbles will be formed, boiling starts, right, and these bubbles, when they go in a high pressure zone and collide there or burst there, then large quantity of energy is released, and because of that the performance of that machine is affected negatively, as well as because of this bursting of the bubble, energy is released. Because of that the walls are eroded. So that's why it may lead to collapse of that machine structure. So for that we must keep some factors in mind, and the most important factor is vapor pressure. So to understand what is vapor pressure, we have this figure. In this figure we have a liquid filled in container. We have a liquid filled in this container which is closed. Now we have a property of the liquid by virtue of which the molecules at the top surface, they gets converted into vapor, and some vapor molecules gets converted into liquid. Now this phenomena will keep happening till these vapor molecules and liquid molecules reach into equilibrium condition. What is equilibrium condition? That number of molecules are converting into vapor and number of vapor molecules are converting into liquid becomes same. In that condition, this type of phenomena is under equilibrium. Under equilibrium condition, these vapor molecules exert some pressure on the free surface. So that pressure is known as vapor pressure. So vapor pressure should not be mixed with partial pressure. This vapor pressure will come into picture when we have a equilibrium condition. So under equilibrium condition, the vapor molecules exert pressure on the liquid surface, and that pressure is known as a vapor pressure. And when vapor pressure is equal to the net pressure on the surface, if total pressure on the surface is equal to vapor pressure of that liquid, then fluid starts boiling, and because of the boiling, bubbles are formed, and these bubbles, when they will go in a high pressure zone, will get bursted, and because of that high energy is released and cavitation phenomena occurs. We have a table here. In this table we have a saturation or vapor pressure of water at various temperature. On the left column we have a temperature of water minus 10 degrees centigrade to 300 degrees centigrade. As we increase the temperature of water, then saturation pressure or vapor pressure will keep increasing. So for minus 10 degrees centigrade it is 0.260 kilopascal, and for 300 degree centigrade it is 8581 kilopascal. So with the help of this property, let us say we want to design a machine in which water temperature will remain 20 degrees centigrade throughout the structure. If water temperature remains at 20 degrees centigrade, then corresponding vapor pressure is seen from this table, which is equal to 2.34 kilopascal. So, nowhere in that system the vapor pressure or total pressure should reduce to 2.34 kilopascal. If vapor pressure total pressure goes to 2.34, in that case the bubbles will start forming or boiling will start and cavitation phenomena will occur. So, to avoid cavitation we must keep this thing in mind, that vapor pressure is 2.34 for 20 degree centigrade. So, it means that the total pressure in that system should not be equal to 2.34 anywhere in the system for avoiding the cavitation.